All right, let's start this off. We're going to review here. Be ready for some brutal honesty about what we should know, what we've already reviewed. All right, because a lot of these questions, I believe, were not the same, but pretty much the same topics we've been reviewing over and over again. All right, so let's go. Questions. Let's get them done. Let's go, Avery.
Number 6.
Okay, 6. Circle fact. All right, circle fact. That's all this was, right? Circle fact. What is ADB and AEOC? What are those? Those are called what in the diagram? Secants. This rule applies to secants, tangents, or one secant and a tangent in a diagram. And that is the following. The whole secant times its external part is equal to the whole secant times the external part. So that's what I need to end up multiplying. There's no adding and subtracting here. That's what I need to end up multiplying. So let me take the first secant they give me info about, which is AB is 12. So everyone see the whole secant is 12 there. And the external part, DB, they give me 6. So what am I writing for my external part? Thanks, Matt. What am I going to write for my external part? The internal part, 6. The whole thing's 12. So the external part also 6. Done. Good so far. Now they tell me, let's see, where are you? AE is 4. Find OC. What's OC? What did I just label X? Radius. So how long is OE? Well, let me back up. What is OE? What is OE? A radius. What do we know about any radii in the same circle? Good so far. How long is that secant then? Add each piece up. How long is each secant? How long is the whole secant? 4 and x gives you what? 2x plus 4 times its external part, which is? Here we go. Okay, here we go. Whole thing times the external equals whole times the external. Tangent, secants, or one of each. Next. Tammy.
15.
Yep. What do I know about the two triangles? What do I know about the two triangles? Similar, angle. The one I gave you, and they both have angle C in common, correct? Angle C, no, angle U in common. So everyone sees angle. Similar means their sides are in the same ratio. We're still having issues with matching up the sides. So let me do this again for everybody. I take a side. Let me take 5. Do you see what angle 5 is across from? The one that's congruent to what in the big triangle? Angle OTU is across from 5. What angle's congruent to OTU? C. So the side that matches up with 5 should be the side across from angle C, which is SU, x plus 4. Do you see what I'm doing there, guys? I'm not trying to move angles or draw them out. All I'm saying is the side across from this congruent angle matches up with the side across from that congruent angle. That's all I'm trying to do and help you out with. We see that. What's the other side in the small triangle I haven't written down yet? 4. Do you see what angle 4 is across from? TOU. Name the angle that's congruent to TOU in the big one. It's the only one that's left because U is congruent to U. What's the only one that's left? Griff. S. What side is across from S? 12, 7 and 5. There's my proportion. Look across from the congruent sides to see what's, excuse me. Look across from the congruent angles to see what the corresponding sides are. Also, if anybody had 7 or just X in their proportion, guys, those aren't even full sides. I can only use full sides of similar triangles when I write my proportion. All right? Next, here we go. And then I cross multiply and I get 11. Others we want to go over. Come on. Avery?
5.
5, everybody. And also, ask a question on, you may have gotten it right, but you know darn well you just guessed. You might want to ask those. Because there was, and I'm not going to do it unless somebody asks, but I can't tell you how many people I saw in this period and last period. Where is it? The circle equation one, where you had to complete the square. 14. I didn't see any work, but somehow magically we got the right answer. How can you get the right answer by not even completing the square? That's just a guess or good eyesight to me. Okay, that's all it is to me. So if you had no idea how to do one, but you got it right, you might want to ask that one too. All right, so going back to 5. 5 is another circle fact I need. Instead of secants and tangents, what am I dealing with at DC and AB? What are those? Chords. Those are chords. Here's the fact about 2 chords that intersect. They're always broken up into 2 segments. So DE is with segment EC on the full chord. A lot of people added them. You got to multiply them. That's equal to the 2 parts of the other chord, AE and EB. All right, so we were looking at 2x plus 8, not plus, but times 3 equals 4x minus 3 times 4. And remember, I just distribute here. I'm just going to distribute to get 3.6. All right. Circle facts. Circle facts. Others. All right, I'm going to pick one then because this was commonly missed. Number 11. Okay, here we go. It's already a parallelogram. Which one will not prove it's a rhombus? Basically, which one of these is not a rhombus property? So first thing, AC congruent to DB. What are AC and DB? Those are what in my diagram? AC and DB. Diagonals. Are they congruent in a rhombus? Are diagonals congruent in a rhombus? So it's not going to make it a rhombus. A lot of people chose 2. AB congruent to BC. Well, remember, it's already a what? Parallelogram. So if AB is congruent to BC, what's AB also congruent to? DC, because it's a parallelogram. What's BC already congruent to? AD, because it's a parallelogram. And notice, what do we know? All 4 sides congruent. It's a rhombus. And then the other big one to pick was AC bisects DCB. That's a property of a rhombus. Diagonals bisect each other, and the angles they're drawn to. That is a rhombus property. So 1, 3, and 4 were all properties. I'm sorry, 2, 3, 4 were. 1 was not. They're not congruent. Diagonals are congruent in a rectangle, not a rhombus. Others you want to go over? Yep, Ava? 14. Here we go. Only way I'm going to figure it out is if I complete the square. Okay, complete. I don't know how else, unless you guys have a magic way I'm not aware of. What do I add? What do I add? Got to add the same thing to the other side. Don't forget about it. How do I figure out what do I add? What do I have to do with the 6 in this case? What do I do with 6? Cut it in half and square it. 3 squared, 9. -4 divided by 2, -2 squared, 4. Add it over. The only thing you could do right now is cross off the ones that have 36 with them because you know that's r squared. Let's keep grinding away. Two numbers that multiply to 9 but add to 6. 3 and 3. Positive 3. I saw a lot of negative 3s on papers. Positive 3. It's got to match that sign. It's got to match that sign. And then over here, two numbers that multiply to 4 add to -4. Y -2. All squared. So when I find the center, I just take the opposite signs of each. -3, +2, radius of 6. I know it's going to be on there. Just are you going to be ready? Questions? Am I upset about these? No, I'm not. Not at all. All right. I seem very passionate about it because I know what's coming, and I don't know if you do. What do you got? 5 exams? 4? 4 or 5? Okay. I get it. That's a lot of stress on you guys. All right. You're not alone. All right. Most of the other freshmen are there too. Am I saying math should be top priority? Absolutely not. But I am letting you know, if you start studying the 18th, 19th, and 20th and think you're going on a 3-day bender of math studying to get ready, it's not going to help. It's going to be too overwhelming. Okay, it's going to be too overwhelming. I'll give you more details about it next week. I'm planning on coming in on the 18th in the afternoon. I think noon to 2:30, and the 20th too. I think 11 to 2 maybe. That we don't have school that day, so I'll be here from. I think it's from 11 to 2. I'll post it on Classroom and tell you guys officially next week. All right. Any other time, school time, I'll be here. I'm not going anywhere. All right. So if you don't have a test in the morning or afternoon, or you're getting off of one in the morning and you don't have anything in the afternoon, I'll be here to review. I'm not going to post times or anything, but the 18th and the 20th are the times outside of the usual school day that I'll be here. Okay. Yes, you can bring if you have. That's a big if. If you have friends too that take the geometry Regents, you can bring them. Okay, but I'm not doing algebra 2. I'm not doing algebra 1. Only geometry, and it's a work session. If you're going to come to one of these, it's a work session. Either bring questions or Regents exams to work on. All right, it's not a big party social hour time. Hang out with me. All right, it's business if you come here. You can come and go as you please too. You come for 10 minutes, you come for 10 minutes. You stay the whole time, you stay the whole time. It's come and go as you please. All right, so that's the deal with the review sessions. Any questions? All right, you still have your August 2018 exam up. There's a couple of unique problems that I want to go over with you today with the time we have left. Okay, go to 28. 28, please. 28. August 2018. 28. Momo, did you ask about this the other day?
Yes.
Okay. Somebody asked same exact question, same exact day in period 2, so I thought it'd be a good idea as a class if we went over one here. All right, if you forgot Mahmoud's question, it was basically, hey, is there any strategy to these type of problems other than just guessing and checking? All right, how do I map one figure onto the other without just trying to guess and check? And let's do this as a full class now. So how do I get that trapezoid ABCD onto the double prime one? My first suggestion to Mahmoud was the following. Check the order of the vertices. So you do that right now. Are the order of the vertices staying the same, or are they opposite each other? Basically, are they both clockwise or both counterclockwise, or are they opposite of each other? What do you notice? A, B, C, D, A double prime, B double prime, C double prime, D double prime. Are they in the same direction? We called it orientation, or are they in opposite ones? What are we noticing? Same or opposite? Same. Everyone, if you want to know how we know it's the same, look. A to B, B to C, C to D, D to A. That is what? Ooh, counterclockwise. Go the same order. Notice I'm going counterclockwise again, right? So because I'm going the same direction, the same orientation, probably doesn't have to involve a reflection. Reflections are the only ones that change orientation. Are we all in agreement that this is probably going to be a rotation? Some sort of rotation. But I need to know how many degrees. And this was the other suggestion I had to Mahmoud, which is take a look at A to A prime. How many quadrants do I have to go through to get there? How many quadrants do I have to go through to get to A double prime? Oh, in quadrant on one, and then now I'm in a second quadrant, right? So if I have to go 2 quadrants, probably what's the number here of degrees of rotation? 180. All right, so those are my tips to you guys. See if the orientation changes. It might be a reflection. And then if it's a rotation in your mind, how many quadrants do I need to go through? So here's what I did. I said, all right, I can tell it's a rotation of 180. So I start describing a rotation of 180 degrees. And I am missing a detail here I want you to fill in. Anybody know what other detail I need to tell you? Or you need to tell us about your rotation? You can have that. That's fine. If it's not in there, that's fine. I'm looking for something else, though. And maybe this is confusing to you because it doesn't matter because it's 180. But what if it was 90? Or 270? You got to tell me what, Caitlin? And clockwise, counterclockwise. All right. So a rotation of 108. And it doesn't matter because we end up at the same spot. So clockwise, about the origin. But unfortunately, go ahead. I'm not done. Go ahead.
No, I just had a question about how you read it. Like, do you have like?
Oh, I'll get to that. Yep. Caitlin?
Could you just like? I have a different way of doing it.
Yeah.
Could you reflect it?
Can I finish my way?
Yeah. Go.
Okay. Can I finish my way? Yep. Yep. That's all part of my process here. Yep. A rotation of 180 won't do that, by the way. It won't get this onto this. Because it'll get A onto, and I do the same thing I teach you guys here. Hey, there's my trapezoid. I turned it 90, 180, and I'm like, where's point A now? 1, 2, 3, -2. 1, 2, 3. That's where A prime would be. So I'm not there yet. I still need another transformation. How do I get A prime onto A double prime now? What transformation's needed? Followed by. What else is needed? Griff? Of what? By a translation down 2. Yep. Don't tell me a translation of 2 or -2. I need to know up, down, left, and right. So that right there is a good answer. Now, I'm going against what I've been preaching to you because of the time we have, but you have 2 to 3 hours. That only works for A. What else do I need to check? That only works for A to A double prime. What else do I need to make sure of? B, C, and D, all 4 of them follow this rule. All right, all 4 follow the rule. Now people have been starting saying, hey, can we write it a different way than out in words? Yes, you can. I've seen a lot of this from you guys. You guys use the composition symbol. Where should I put a rotation of 180 if it's going to be done first? Yes, to the right. A rotation of 180, and then I keep working backwards with what I want to do. And this comes to Paul's question. Here's one way I can do a translation down to. And I'm going to be picky here. This is not good enough for me. This right here is not good enough. How many figures are on your graph? How many figures are on the graph? 2. Which one you doing this to? Well, I'm not assuming it's the single. I'm not assuming it's A, B, C, D. It could be the other one. So we got to put down, hey, I'm doing this on A, B, C, D, not the prime, double prime one. So get specific if you want to write the composition. Mahmood.
So you can still keep it in words.
Yeah, absolutely. Yeah, that's fine. Yep. Caitlin, this is one of, I think we came up with 3 different ways. My way, and then 2 other people in second period had different ways. Go ahead.
Mine takes 3 steps.
Yeah, I know. Good. It should.
Reflection over the x-axis.
Yep.
And then translation of that and then reflection over the y-axis.
Yep.
But like, if it says A, B, C, D double prime, like, would that have to be 2 steps or like?
Oh, you're fine. That's fine. Yep. Now, some of you may have heard Caitlin's explanation, and you're like, whoa, whoa, whoa. I thought it didn't involve a reflection because that would change the orientation. But how many reflections did you have in? 2. Do you see what happened? I reflect once, it changes. I reflect again, we go back to the original. So 2 reflections would be fine. Yep, Mahmood.
When it says maps, does that mean that, like for this question, A had to line up with A and B had to line up with D? Will that be it for the other, like all the other questions that we do that say maps?
Correct. The first letter has to map to the first letter. Second letter has to map to the second letter.
Which ones, like what questions would ask where that would be different? Like would it be just on to a different one? No.
The letters always match up for a reason, right? How much of a stickler was I this year when you wrote your, like, this triangle's congruent to this triangle? What did you always have to make sure of? Angles and sides matched up, right? Paul?
Just going off Caitlin's, can you just do a reflection over y equals -1?
Yes.
Just
That was the other way second period came up with. Correct. Mm-hmm. Flip it over the y-axis, and then flip it over y equals -1. Yep, that was the other way. Anything else on this problem? Good discussions here. We're all good? Okay, we have done a lot of dilating of lines. Anybody want to help me out here? When you dilate a line, it remains what to the original? Parallel, remains parallel, right? It remains parallel to the original, which means it has the same what? Slope. How do we get the y-intercept? We just multiplied the old one by the scale factor. That only works if we dilate around the origin. And this one is not. Oh, looks like it's giveaway time. Lucky us, huh? Looks like it's giveaway time. 19? Oh, giveaway time. Let's see what I got, Caitlin. Giveaway time.
19. That's what I said. Yeah.
What the heck?
Yeah.
Let's see what I got here for Caitlin. Giveaway time. Let's see. Dry erase tip markers. Holy geez. Whole bag of kisses. Stack of Post-it notes. King's Kit Kats. Snacks. No. Oh, little Reese's Pieces. I don't know, Caitlin. Oh, this little furry Santa Claus thing. Don't know what that is. I think we're good, Caitlin. You're not getting anything out of the bag. Congratulations. You just got yourself a new tie-dye junior class t-shirt. Yes. Save it another year. It'll be worth it. There you go. Congratulations. Who knows what's coming out here? Got more than what's in the bag. All right, so let's look at 30 here. We're going to dilate this line. 4x plus 3y equals 24. Dilate it by 2, and Aaliyah says, here's the equation of the new line. Is she right or wrong? Well, let's go through the process we would do without knowing Aaliyah's answer. We would know if we're dilating, the slope stays the same because the lines remain parallel. So I need your help first finding the slope of this line. First step to finding the slope of this line. That's what I thought, minus 4x, good. 3y equals negative 4x plus 24. Divide by 3. We end up with y equals negative 4/3 x plus 8. What's the slope of this line? Negative. So what's the slope of my dilated line? Negative 4/3. So it looks like she's good so far. How do I find the new y-intercept? This is how we've been finding it. I've been taking the old y-intercept and multiplying it by the scale factor. So you're like, oh, the old one was 8. I multiply it by the scale factor. The new one is 16. She's good. No. This can only happen if I dilate around the origin. I can multiply it by the scale factor. Am I dilating around the origin? No. So what do I do now if I'm dilating around another point that's not the origin? This is why I'm reviewing this with you. Let me just show you, and you can graph it too if you want. What's this bad boy look like on the graph? Let's see. Y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. Slope down 4/3. Here's the line right here. Oh boy. Here we go. There's the line. Locate the center we're dilating. It's not the origin anymore. Locate where 3, 4 is. Notice anything? Where's 3, 4 land? Right here. It's already on the line. Anybody remember what happens if I dilate? I don't care what the scale factor is, 2 or 200. If I dilate a line where the center of dilation is already on the line, what happens? Avery? Nothing happens. The original line and the dilated line remain the same if I dilate around a point on the line. You can only use this multiplication trick if it's around the origin. All right? Let me write my answer, and I'll be right with you too. So is she correct? Heck no. Sure, go ahead and write heck no. No. When the center of dilation is on the line, it remains the same. All right. You can only multiply by the scale factor if it's around the origin. Mahmoud, I'm ready.
What happens if it's not?
Is that your question, Sukan? Yeah. I figured that would come up in an honors class. What happens if my point's not on the line, right? Okay, great question. Okay, can I keep this? Is this all right? Keep this same line? And let me dilate around this point. I don't know. I want to try to keep it close. This line's in a cruddy spot. All right, I'm just going to go with it. All right, say my center of dilation is there, and I want to dilate around 2. Okay, so how do I do that? Are these points going to get further away or closer if I dilate by 2? Further away, right? So I'm going to take a point I know is on the line. So I'm going to start with this point right here. And it looks like I go over 1, over 1. Nope, I just go down, don't I? 1, 2, 3. So I go 1, 2, 3. There's my new point on my new line. Good? All set there? All right, let me do another one here. So I go up 1 over 1, 2, 3. So again, up 1 over 1, 2, 3. So there's that point led. How many points do you need to make a line? Just 2. So now you can graph it in if you want. Is the slope going to change? Slope's not going to change, right? So I still know it's going to be y equals negative 4/3 x. Now, how do I find the y-intercept? Same way I've been teaching you guys how to find the y-intercept. Plug it into y equals mx plus b. Solve for b. But where do I get a y or an x coordinate from? The new point. So you pick one of those points, plug it in for y and x, and solve for b. Good? All right, so individually dilate 2 points on your original line. Use one of the points into y equals mx plus b and find your y-intercept. Tammy?
Well, let's say like the scale factor is like 1/2 or
Yep.
something, and we're dilating around that point.
Hopefully they give you an even number, right? Because this would be 1, 2, 3, and you have to go 1.5 in between. All right, and then what did I do for the slope here? Up 1 over 1, 2. Yeah. Hopefully they give you even numbers because then I just cut it in half. So whatever I go up and over, cut it in half, and then I go up and over that many instead. Okay. Great questions here. Anything else? Go ahead, Eva.
So, like, if the scale factors, so if it's just like any number, then you just move that amount of times, like.
Yep. So here you go. Let me get a fresh slice up here.
Please excuse the disruption. Tickets for A Midsummer Night's Dream are still available. My school bus sales close the day before each show, but that doesn't mean the show is sold out. Tickets can also be purchased at the door for $5 each, cash only. Hope to see you there. Have a good weekend.
Okay, so let's say dilating by 2. This is my center of dilation. I want to dilate that point. Dilation of 2, so it's going to get further away. So down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Let's say my scale factor is 3. Let's do it again. Down. What do we go? Down 3. 1, 2, 3 over 1, 2. Okay, we're going to keep going and going. All right. Yes.
Would we ever have to dilate a figure like triangle or something?
Could be. Just take each vertex now. Don't think of it as a triangle, Charlotte. Think of it as 3 points to dilate, just like I dilated this point. Okay, take your for one vertex, up and over how many? Do it again. Okay, and I can also see a construction too. We do constructions with dilations too, so make sure we look at that. But yeah, don't look at it as, if I want to dilate this triangle, don't look at it as a triangle. Look at it as dilate that point first. Dilate that point, dilate that point. Okay, and then you'll get something that's either bigger or smaller. Other questions? Okay, I told period 2, I'm not going to assign anything anymore. We got 2 more class days left. You guys are hopefully coming up with your own study pattern right now, so I'm not going to tell you what to do. That's up to you. I'm here today after school. I'll be here Monday after school as well. All right, so that's on you guys. We'll do probably some more multiple choice on Monday. Behave this weekend. Nothing stronger than ginger ale.